So this is lesson 5. In this tutorial we're going to talk about the SubBytes. We already talked about the Xbox in the last tutorial. So the SubByte is what actually uses this Xbox. The Xbox is more like the lookup table. The SubByte is what actually use it. So on my website projectfpga.com/AES, select SubBytes. You are going to see the brief introduction on SubBytes. Then you are going to have the Verilog code also here. This is the Verilog code, and one thing about this is that they are very short and easy to comprehend. Then this is the Logisim circuit. It probably looks a little bit complex, always because of one reason I already told you about. I always split the inputs 32 bits all the time. So an input that is actually meant to be 1 is going to be 4. That is 32 by 4, which is 128. But what essentially happens here is just what we explained about the Xbox in the last tutorial. So the Xbox serves as a sub-circuit to this circuit, the SubBytes. So what the SubByte does is it has the inputs and it expects the outputs. So it takes its inputs and feeds it into the Xbox, and whenever it feeds it into the Xbox, it receives the output. So the Xbox sub-circuit does the lookup, the job of doing the lookup. So as usual, we have our clock and reset. Now we have again this validing. So whenever we're done giving the input, we are going to select that the inputs are valid by turning on this validing input, and then at the end we are going to get all our outputs is going to come on, all our outputs with the valid out. So you're going to see the valid out throughout this model. Why? Because of the rounds. So for you to move from one round to another, the valid out, this valid out must turn on to say that yes, this particular round is complete, therefore move on to the next. So when we are going to be talking about the round, you are going to see the effect of this valid out is very important. If this valid out doesn't come on, we are not going to go over to the next round. So that's the reason why we have this valid out. The job is actually to initiate the next round that you're expecting. So as usual, I would like to simulate this for you in Logisim. I'll get the clock again, then so you watch. Then why it looks so complex is, remember, this is the Xbox. The Xbox takes only 8 inputs. So now let's go back to the SubByte. So now let's do a simple math here. If each of these Xbox takes 8 inputs, now how many total of how many Xbox we have here? Then we have 1, 2, 3, 4 multiplied by 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, wait, 12, then 13, 14, 15, and 16. So let's multiply 8 bits by 16. Yes, that's it. Let's use this calculator and do 8 multiplied by 16. 8 times 16, which is equal to 128. So this is the 128 bit single input we are supposed to put into the Xbox and get a 128 bit output. So let me do the simulation here. So exactly what we did in the last one, but this time let's see. So I'm going to use different values for the inputs, and watch how the Xbox takes these inputs and obfuscates them as usual. It finds them in the lookup table and changes their value actually. So let's see. So remember, don't mind these outputs. Just like I told you, is a RAM and it always have data last. So don't mind this current generated outputs. By the time we turn on the valid in on, they are going to change into the actual values we need. So is on. Then let me turn the valid in on and watch how these outputs are going to change. So you can see how I label them out 1, out 2, out 3, and out 4. So when I turn the valid in on, it has changed. So this is how the SubBytes works. So the SubBytes is actually the top level circuit for the Xbox. So what the SubByte does is it holds the inputs and outputs for the Xbox. So thank you for watching.